Viewers, in this video we will solve problem 29 from the book Heat Transfer J.P. Holman 10th editions from first chapters. Here is the statement. A 5 cm diameter cylinder is heated to a temperatures of 200 centigrade and air at 30 centigrade is forced across it at a velocity of 50 meter per second. If the surface emissivity is 0.7, calculate the total heat loss per unit length if the walls of the enclosing room are at 10 centigrade. So what is the diameters? Inner dia that is provided of the pipe, that is 5 cm, divided with the 100 to convert into meter, and you will get that is 0.05 meter. Next, the temperature at which it is heated, that is Ti, and that is 200 centigrade. Convert into Kelvin, so add 273 with it, so you will get that is 473 Kelvin. Next is the temperatures of the air that is flowing in the pipe, that is TW, let's say, and that is 30 centigrade, and the velocity of the air that is flowing in the pipe, that is 50 meter per second. And the surface emissivity is, and the surface emissivity that is provided is 0.7. we need to find total heat loss per unit length. So we need to find total heat loss per unit length of this pipe, and the outside temperatures, that is 10 centigrade. So let me draw a sketch that will understand you the scenario of this problem. So this is the pipe in which air is flowing at the velocity of 50 meter per second, 50 meter per second, and its temperatures, that is 30 centigrade, and that is TW, and the inside dia that is provided, that is 0.05 meter. And also this pipe, the cylindrical pipe, is heated at the temperatures of Ti, let's say this is the inside valve temperatures of this pipe, and that is Ti, and that is 473 Kelvin or 200 centigrade, and the outside temperatures, that is 10 centigrade. So we need to find the heat loss per unit length of this pipe. So first, in the first statement, if you consider the heat transfer between 200 centigrade and 30 centigrade is a convection heat transfer loss occurs, because when air is flowing inside this pipe and the cylinder pipe is heated at the temperatures of 200 centigrade, that is 200 centigrade, so when this air is flowing with a high velocity, so convection heat transfers will occur. So what will be the convection heat transfers coefficients? Then you can notice from the table 1.3. Here I extract the portions that is or under study considerations. If airflow is flowing in 5 cm cylinder with a velocity of 50 meter per second, its convection heat transfer coefficients will be 180 watt per meter square centigrade. So convection heat transfer is equal to HA, temperature difference, that is Ti minus TW is the temperatures of the air. Now Q, convections, H, A is the surface area of this pipe, that is pi d L. So we need to find heat transfer per unit length, so we will divide it with L, Ti minus TW. So this L will be cancelled out with this, so you will get heat transfer per unit length. So I will write it QC. QC means convection heat transfer per unit length. What is H? That is 180. What is pi? That is 3.14. What is D? That is 0.05. What is Ti? That is 200 minus Tw, that is 30. So after simplifications on calculators, you will get its value, that is 4807 watt per meter. Now the heat transfer that is occurs, so there is no medium, let's say. So the heat transfer from the wall to the enclosing room, that will be radiation style. So heat transfer from the pipe to the room, that is radiation heat transfer, and that will be equal to and we can solve this according to Stefan-Boltzmann law. So what Stefan-Boltzmann's law? It's very easy, and that is sigma emissivity, surface area, and the fourth power of the absolute temperatures, that is Ti and T0. So in this case, Ti is the wall temperatures and T0 is the outside, the pipe temperatures through which heat transfers through radiations is occurred. Okay, next is the heat transfer to radiations is also equal to sigma epsilon, area is pi d L, so again divide with L, Ti to the power 4 minus T0 to the power 4. Why we are dividing with L? Because we are interested to find heat transfer per unit length, that's why. Now the things are very easy. So the heat transfer to radiation per unit length is equal to, what is sigma value? That is constant, and that is equal to 5.66 multiplied by 10 to the power minus 8. What is emissivity? That is 0.7 provided pi d 0.05 multiply Ti, that is 473 to the power 4 minus 283 to the power 4. So after simplifications on calculators, you will get heat transfer of radiations per unit length. You will get, that is 272 watt per meter. So this is the heat transfer that you will get through convection heat transfers, and this is the heat transfer you will get through radiations. So add these two equations, you will get the total heat transfers per unit length. So QT means total heat transfer per unit length. You will get, that is Q convections per unit length plus Q radiations per unit length. So what is total heat transfer per unit length? That is 4807 plus 272. If you add that, you will get the value, that is 5079 watt per meter. This is the total heat transfer per unit length in case of loss that it occurs through this pipe. This is our final answer. I hope you understand. If you still have any confusion, you can ask in the comment section. And the one more important things here, it's a comment on the calculation, on this calculation. So from these calculations you can clearly observe that heat transfer through convection is more as compared to radiations. So you can comment on these calculations accordingly when you obtain the data. Subscribe my channel if you haven't subscribed. Thank you so much.